Tired of homework headaches? MyAssignmentHelp is your personal study coach. Let's conquer your academic goals together. Our task is to design and implement a JFLAP Turing machine to validate and store encrypted strings of given pattern for the first name and the last name. We need to encrypt letters as their alphabet successors, with Z wrapping to. Also, we have to test the string that should be accepted, but throw in a rejected string. The solution you're looking for is on its way, so stay tuned, keep watching, and let's unravel the insights together. Before delving further, first thing we need to know is our objective, which is to develop a Turing machine using JFLAP to validate strings following a specific pattern as shown. Remember that the letters are replaced with their alphabet successors. Moving further on Turing machine components, the Turing machine is like a conductor orchestrating a melody of states. It begins in Q0, navigating through Q1 to Q8. Reading, counting, and checking, each state has its role. It's a swift, precise dance that either accepts or rejects encrypted names. Now let's move on to the transition rules required for transition function. The Turing machine embarks on its journey starting in Q0, where it reads a blank symbol, writes an R, and moves to the right. Forward through the loops and checks, and the grand finale unfolds in K7. At this pinnacle, the machine reads a blank, writes a blank, and elegantly halts. The curtain falls on a successful validation. You can go through each step as shown. We have covered the rules. Now, let's formulate the transition function in a more streamlined manner. The Turing machine starts in Q0, reading a blank and smoothly transitioning to QA. Entering a loop in Q1, it scans for the encrypt. Upon encountering is in Q2, it counts the first name letters. Moving to Q4 from Q3, it checks for and counts the last name letters, rejecting if AT is absent. In Q6, it checks if the tape is empty, accepting in Q7 and rejecting in Q8 accordingly. This succinct dance of transitions encapsulates our Turing machine's elegant processing of encrypted names. Now, the function created is need to be verified using JFLAP. Here are the steps for implementation. First of all, create a new Turing machine project in JFLAP and then define input alphabet and tape symbol. You need to add states in Chalishal and accepting. Akavan, rejecting. Implement transition function from the provided table. Lastly, test with diverse input strings for verification. Thus, these steps will unveil the verdict of acceptance or rejection, offering insights into how well your Turing machine interprets and processes the input string. Here, the output we got from verifications in JFLAP is as shown. The input provided metamorphoses into the accepted Aluxiwayasame. However, BMJ babita injection, this is due to a mismatch between the encrypted first name length and the actual number of letters. Hence, in light of our design and observations, we concluded that the designed Turing machine, implemented using JFLAP, effectively processes and validates encrypted names based on a specific encryption logic. By carefully defining states, transitions, and processing rules, the machine reliably identifies and accepts valid input strings while appropriately rejecting invalid ones. Seeking instant assignment help and homework assistance, our dedicated team is here to support you with quality guidance and resources, making academic success a shared journey. Connect with us for all your assignment needs.